Earlier, I made the statement that if you have an isosceles triangle, that is, if you have a triangle, call it triangle ABC, where two sides are equal, then angle 1 and angle 2 are in fact equal. We're going to prove that. So we have this theorem. If two sides of a triangle are equal, then the angles opposite them, down in E, opposite them are equal. Opposite BC is angle 1. Opposite AB is angle 2. And those angles are equal. So proof. Statement and their corresponding reasons. Okay, first, let me clean up this picture a little bit. Okay, so AB and BC line segments, they're equal. Why? That was given. Draw a line from point B to the midpoint of AC. Call the midpoint D. What's the reason? Construction. Number 3. AD is congruent to, guess these should be congruent. Hate that symbol. AD is congruent to DC. Why? A midpoint divides a line segment into two equal parts. And of course, you should write out these words. Line segment, equal. Okay. Number 4. BD is equal to BD. Reflexive property. Okay, so let's go over carefully what we have so far. Statement 3 says that AD and BC are equal to one another, congruent. Statement 4 says that BD is equal to BD. Well, we have two triangles. We have the left-hand triangle, we have the right-hand triangle. We can now say that triangle 1, triangle ABD, is congruent to triangle 2, which is CBD. And the reason is SSS. Side, side, side is congruent to side, side, side. And that's number 5. Now we are done. Statement 6. Angle 1 is congruent to angle 2. The reason is corresponding parts congruent triangles are congruent. Now, why are they corresponding parts? Well, angle 1 comes from these two sides. The side with one slash and the side with two slashes. But that's what angle 2 is made up of. Those two sides. Angle 2 is made up from those two sides. One with one slash and one with two slashes. They are, in fact, corresponding parts of those two congruent triangles. So they're equal and we're done. Okay. Let us reverse this now. I want to say that if two angles of a triangle are equal, then their opposite, this should have said sides, sorry. Actually, this should have said angles. Then their opposite if two sides of a triangle are equal, then the angles opposite them are equal. I had it right. Now I want to say sides. Then the sides opposite them are equal. Just reverse it. If two angles are equal, then their opposite sides are equal. So, like always, we are going to start off with a triangle. Triangle ABC. And I am giving you that angle 1 and angle 2 are equal. And what we need to conclude, so you're given angle 1 is equal to angle 2. And you want to prove that the opposite sides. Opposite angle 1 is BC. And you want to show that that's congruent to the side opposite B, which is line segment AC. And I guess we'll prove it the same exact way. I'll go to the midpoint and I'll come straight down. So then we know that AD and BD are equal. And we know that CD equals itself. And we know angle 1 and angle 2 are equal. Well, all right. Statement reasons. We are given that angle 1 is equal to angle 2. This is given. Statement number 2 is that, actually, we're not really going to use this midpoint. I changed my mind. We know that AB is congruent to AB. The reflexive property. And statement 3 is that triangle ABC is congruent to triangle BAC. And this is by angle, side angle. This is by angle, side angle is congruent to angle, side angle. Now, what we're doing here is we're thinking of this triangle as two separate triangles. I'm going to draw the mirror image over here. I'm going to draw the mirror image. That is, this is A, and this is B, and this is C, and that's angle 2, and that's angle 1. Well, we're given that the two angles are equal. We're given that, well, I do have one typo, 2 and 1. We're given that this angle and this angle are equal. Angle 1 equals angle 2. And we're also given that those two angles are equal. In fact, they're equal to one another. Those four angles are equal. And of course, AB and BA are equal. Those are the two statements that I said. So now these two triangles, triangle 1 and triangle 2, they are congruent. They are congruent. And now I can say that AC and BC are corresponding parts and hence are equal. Corresponding parts of congruent triangles are congruent. Now, why are they? Well, for example, opposite 2 is AC, and we know that opposite 2 is AC, and we know that 1 and 2 are equal, so that's the same as angle 2, so opposite 2 is BC. And now we know that they're equal. Okay, so that's that problem. That proof. Very important. So basically, if two angles are equal, then the opposite sides are equal. If two sides are equal, then their opposite angles are equal. Which means, to prove that a triangle is isosceles, it's enough to show that either two angles are equal or two sides are equal. And of course, I should say at least. Now, here's an interesting problem. Suppose you have a triangle A, B, and C, and you draw these two lines, EF and GH. And you were told that this angle and this angle are equal. You are given that angle 1 equals angle 2, and you're also given that the lengths of EF and the lengths of GH congruent. And I guess you also need that AE and, well, let me do it the same here. And BG, they're the same lengths. So, angle 1 equals angle 2, EF and GH are equal, and AE and BG are equal. And what we want to prove is that those base angles are equal. We want to prove that angle A and angle B are, in fact, equal to one another. Okay, and the idea is that supplements of equal angles are equal. That is, whatever angle 3 is, it must be the same as angle 4. And if that's true, and it is, let me put 2 slashes. If that's true, then this little triangle here and this little triangle here are congruent by side angle side. And then by corresponding parts of congruent triangles, angle A and angle B are equal. Okay. So first, we need to get angle 3 and angle 4 to be the same. Statement, reasons. 1. All of this. The reason given. Now you say that AEC and BGC are straight angles. And the reason is they're a side of a triangle. Triangles are made up of 3 straight lines. So, straight line is a straight angle. Now we're going to say that angles 3 and angle 4 are equal. Now we already know angle 1 and angle 2 are equal. So we say supplements of equal angles are equal. If 2 angles are equal, then the magic number you add to these angles to get to 180 will be the same. Angle 1 and angle 2 were both 70. Well, their supplementary, the supplement of 70, the supplement of 70 is 110. And that's true because they add up to 180. The supplement of equal angles are equal. Okay, now number 4. We'll say that triangle AFE is congruent to triangle BHG. Triangle 1 is congruent to triangle 2. And the reason is SAS. We have that side and this side over here. We have these 2 sides congruent and the angle in the middle. Same thing here. We have those 2 sides corresponding to sides in triangle 2 and the angle in the middle. The 2 angles in the middle correspond. These 2 triangles are in fact the same. They're congruent. And now I can say that angle A, is congruent to angle B. And the reason is corresponding parts of congruent triangles are congruent. But are they really, really corresponding parts? And the answer is yes. Now, since they are corresponding, AF and BH are equal. And basically, angle A is made up of the side with 2 slashes and an X. Angle B is the x and the two slashes. They're corresponding. Okay, let's try one more. Now, here's a very standard problem that you should be able to do. You have A, B, C, angles 3 and angle 4. And you are given that AB is congruent to BC. That's all you're given. And you want to prove or show that angles 3 equals angle 4. So maybe the first thing I should do is get rid of those slashes because they look equal. Oops, let's put the marker down first. Alright. So we're given that AB and BC are equal. That immediately tells me that angle 1 and angle 2 are equal, because opposite angles are going to be equal. If two sides are equal, then they're opposite angles. Opposite BC is angle 1. Opposite AB is angle 2. If AB and BC are in fact equal, then so are angle A and B. But 3 and 4. 3 is the supplement of 1. 4 is the supplement of 2. But 1 and 2 are the same. Since 3 and 4 are supplements of the same angle, making them equal. If angle 1 and angle 2 are both 20 degrees, if angle 1 is 20, well then angle 3 is 160. If angle 2 is the same as angle 1, 20 degrees, then angle 4 is 160 degrees. They're equal to one another. You can start off with the same, two students can start off with the same angle, like angle 1 and angle 2, they're equal, and get different supplements. Alright, statement reasons. 1. AB is congruent to BC. Reason? It was given. Now we can jump to angle 1 is equal to angle 2, or is congruent to angle 2. The reason is opposite angles of two equal sides. Okay. If two sides are equal, their opposite angles are equal. That's cleaner. If two sides of a triangle are congruent, then their opposite angles are congruent. And now we're done. Angle 3 is in fact congruent to angle 4. And the reason is supplements of equal angles are equal. So the main thing in this section is if two sides of a triangle are equal, if this side and that side are equal, then their opposite angles are equal. two angles are equal, then their sides opposite them are equal. AB and BC are equal if angle A equals angle C. To show that to show that a triangle is isosceles, therefore to show a triangle is isosceles, all you need to do is show two sides are equal, two or more sides are equal, or two or more angles are equal. One or the other is enough. We don't care if there's a third equal side or a third equal angle. Okay, that finishes this section.